Bonjour à tous, je suis Guillaume Grosbois, nouvel agent de recherche, professeur associé à l'Institut de recherche sur les forêts. Je vais être le modérateur pour cet après-midi. Donc maintenant, on va passer au bloc 4 sur l'historique et la dynamique forestière. So, Emmanuel, Boakye, we will listen to you about contrasting growth response of jack pine and trembling aspen to climate warming in Quebec mixed woods forests of eastern Canada since the early 20th century.
Okay, bonjour. Bonjour. My presentation will focus on the growth response of jack pine and trembling aspen to climate warming in Quebec. Temperature has been increasing in the boreal and temperate forest because our climate is warming up. And in Canada, since the 1900s, temperature has been increasing. And in Quebec, around the 1940s, temperature has been on the ascendancy. And within this ecosystem, tree growth is limited by cold temperatures and relatively short growing season. And therefore, these changes is expected to impact on the growth of trees. Already, studies have shown contrasting growth trends within the boreal region. Positive growth rates have been experienced in areas where soil moisture is available, and negative growth rates have been recorded in areas where water is limiting. And in some studies, no growth changes have been observed. It's interesting to know that most of these studies focused on annual and decadal growth rate variation. However, they do not offer the opportunity to discuss the long-term effect of climate warming on growth. And so the study was to look at how trembling aspen and jack pine are responding to climate change. We expected an increase in growth rate in the two species because of the increasing climate, which is overcoming their limitations. And also we expected that the stand conditions should modify tree growth response to climate. Our study was the boreal mistwood of Quebec, and we used the data of the Ministry of Forest, Fauna and Parks, and we decided to focus on jack pine and trembling aspen because these are shade intolerant species, and therefore they experience limited variation in light condition so that we minimize the influence of management on growth. And so these data were collected from permanent and temporary plots. Tree cohorts were obtained to compute the annual growth increment. And from these, we used the annual growth increments derived from their tree rings together with stand variables. And we used nonlinear mixed effect model, in this case GAN, to integrate tree size, their cambial age, and then the site variables, as you can find on the slide: inter-tree competition, terrain slope, soil types, temperature, and their interactions. And we weighted the growth rate changes between the observed and the predicted and expressed it as a percentage. Here in the next slide, I show to you most of the significant variables. For jack pine, we notice that in any case, for the graphs that you can see on the y-axis is the effect values. That is the effect of cambial age on growth, the effect of slope on growth. So on the y-axis are the effect values. And you could see that the nonlinear effect of cambial age, in other words, during the first 50 years of jack pine growth, trees accelerated their growth because at this point, they tried to avoid competitive exclusion. And between 50 and 120 years, these trees maintain a stable growth. At this point, trees have sufficient canopy, and the amount of increment is more like equivalent to the amount of canopy that they have. And they start to decline in growth rate after 20 years, which is also typical of aging, where there are hydraulic resistance and trees have to develop defense mechanisms, and therefore they experience a decline in growth with age. And similarly, we observe a decreasing effect of slope with growth. In other words, as growth rate tend to increase with decreasing slope. And so we also observe interaction between slope and temperature and soil variables. These findings are not different from trembling aspen, which also experience the effect of age, slope, climate, moisture index, and temperature interactions and soil on the growth. And so we weighted the prediction against the observed in order to express the long-term growth variability. And for jack pine, we observe no significant long-term trend in the growth between 1950 and 2012. So between 1950 and 2012, jack pine showed no significant long-term growth changes. However, trembling aspen have been showing a significant increase in growth rate since the 1950s to date. And so our study, what we can take home is that trees within the boreal mistwood response to climate change may be species specific. And we expect that because of the variability in site conditions, these growth responses to climate will be heterogeneous across the boreal mistwood, which means is that we need to take into account species specific and site specific conditions in defining management prescription on growth. What is yet to be known is how these species-specific growth differences will influence the future composition of the boreal mistwood. And so these are some of the references, and then also those who sponsored me to enable me to do this research. Thank you very much.